So this is our final presentation for biomechanics. We're going to talk about athletes' need profile, and presenting we are
Regina Crespo.
Miguel Gaona.
Eric Pancardo.
and Marco Cruz. So, okay. First of all, it is important to know that knee joint is one of the most affected parts of the human body. Knee injuries can occur in young people, both during sports and normal activities, and sometimes it may even lead to joint degeneration over time. For professional sports especially, these injuries that we're going to be focused on are the medial and anterior cruciate ligaments and the medial meniscus ligaments. These injuries can surely be a problem, wasting time and important resources, and these injuries are usually more severe than injuries in other body parts. This is related to the force applied while practicing sports and the complexity of this joint structure. This kind of injury usually requires extensive rehabilitation, or even if it is a very serious injury, maybe surgery so that the knee can get better. That will also lead to a very extensive recovery time, which is why this is such an important field of study.
Taking this into consideration, we decided to make a proposal to develop a protocol for our college athletes and athletes in general, in which we can measure every certain time how the knee is doing and identify potential risk factors, especially for the athlete, and give proper feedback about how they are doing. So first of all, our proposal is divided in two parts, which is to identify the knee profile of the subject or athlete, and then the tests depending on the knee profile that we previously identified. So first of all, to identify the knee profile, we refer to which types of activities and risks can place the knee at risk of some type of injury. So as my partner previously said, we will talk mostly about the anterior cruciate ligament, the medial cruciate ligament, and medial meniscus injuries. Here are some of the factors that could put you at risk for this type of injuries. So to identify the knee profile is to see these factors and to see like, well, does my athlete is a woman? Does it play soccer? Is it a volleyball player? If they have any of these points, then maybe they can be at risk of having this injury, and we can, but then with the knee profile identified, we can go on to the tests. So for the anterior cruciate ligament injury, we have that it's being a woman, it's being a soccer player, a volleyball player, and having low proprioception. For the medial cruciate ligament, it are sports that involve jumping and landing, recent fractures, and low muscle density. And finally, for medial meniscus, it's twist and swing activities, contact sports, and natural wear by age. So if your athlete has any of these factors, then you may consider having them go through these tests. So after doing a lot of research, we decided different types of tests for each type of injury. For the ACL, we found out that pivoting and running would be a good idea to see, because pivoting is when you're running in zigzag during soccer. And in this type of thing, in this type of test, we will analyze via software, video analysis. And the main part of this is to analyze the angles of the tibia, femur, and hip, because these have a strong correlation to anterior cruciate ligament injuries. Then we have the medial cruciate ligament and medial meniscus injuries. These have the kind of the same pattern. So for these two, we decided to go with jumping, and this would be used with tracker and an accelerometer. We tried to use a force plate, but because of the quarantine, we had to use an accelerometer. It's also worth to mention that if this kind of project was made during normal times, then we would have the time to actually identify the type of knee profile that the athlete has. But because we couldn't, well, we ran the tests anyways.
So to show the results, first we have the test that was carried by the accelerometer. And in this case, as my partner Regina said, we couldn't use a force plate, so we used the sensors of a cell phone. In this case, the athlete that was one of our teammates uh, like taped its cell phone to his leg and performed 3 jumps. First with both legs, then with the right leg only, and then with the left leg only. And here are the results. First, we obtained the forces in X, Y, and Z, and multiplied the acceleration in C times the mass of our teammate. As we can see in this graph, we obtain a regular force graph of a jump where we have 3 phases: the landing phase, the jump phase or takeoff phase, and the air phase, that is the one on the middle. In the case of the jump with both legs, we have that the landing part is like basically well distributed in terms of the force according to the jumping phase. So in this case, we have a good performed jump. But in the next case, using only the right leg, we have an even better perform of our teammate. As we can see, we have a wider landing phase. So this means that the force distributes a long time at the time of the landing. Uh, and finally, using only the left leg, we have a worse perform since we have like not that wide part in the landing phase. So this means that the athlete, when jumping with his left leg, is carrying too much effort or force into his knee. So we would recommend to distribute a long time the force at the time of the landing.
Okay, one of the exercises we made is related with the pivot movement. For this case, we recorded a volunteer by their front side, running to the right and to the left for doing the analysis. We took the knee as a point of reference in the middle of the leg for getting the angle made for each part of the leg. On the table, we can see those spikes that show us the moment when the guy is more prone to get a knee injury. This is when this guy makes a very high angle with one of their leg and the other one is too small. Other of our exercises is running. For this case, we recorded one of our team member by the right side running on a treadmill for doing the analysis. So on the previous exercise, we took the knee as a point of reference in the middle of the leg for getting the angle made for each part of the leg. A common error made running is not to correctly bend the leg. And if the angle made on the leg is higher, the guy running will be on a higher risk to get a knee injury.
Okay, so as a conclusion, we think that our proposal could potentially help to reduce the risk of knee injury on a major scale. Maybe also it's important to know that many athletes are able actually after a certain knee injury to return to the respective sport, but statistically the risk of having a second knee injury increases. This will depending on the type of the first injury, the rehabilitation process, and the time out of the activity. So it is important to check on performance-based measures including this type of knee profiling to acknowledge all types of potential risks. This will, with the proper use of technologies that uh, right now we don't have in hand, or the with further research could help with the prevention and rehabilitation of these injuries, and well, in order to properly design or develop a proper recovery scheme for the injured joint. And that's it. Thank you.
Thank you very much. If you have any doubts, we recommend that you check out our report.